let's say you've got something that's traveling in a circle. So you start here, and it would travel in a circle like this. It could be anything. It could be like a stone tied to the end of a string. So it's traveling around in a circle. Or it could be a funfair wheel traveling around in a circle like this, and you're keeping track of just one part of that wheel. Or it could be inside a car engine where the motor is turning around like this, and then excuse me, and then you're moving the piston back and forth. So it could be anything traveling in a circle. So if you have something, let's say it's here at the moment, okay, and this distance here, let's call it, well, it could be anything. Let's just call it one a unit circle. So just to keep things simple, it could be anything. Let's call it one, so it's quite simple. And let's call this angle here theta. Okay. So if you draw a straight line down here, hang on. So here, this is a right angle triangle here. Um, so if you've got something that's traveling around in a circle like this, you can always find out this length here. Okay. Remember, this this length here, from here to all the way to the end here, okay, is also one, because this distance, hang on, let me clear this up. This distance here is one. This distance here is one. This distance here is also one. Okay. So if you have something like this here, this triangle here, and this is here. Hang on. Okay. This is one, and this distance here, from here to here, is slightly less than one. Okay, it's not one, because you can see there's a gap in between. So the horizontal distance here is actually slightly less than one. Okay, so hang on, let me draw this. So this here, hang on. This angle here is theta, and this is one. Now, if you want to find out x, remember x is this distance here, which is less than the radius, less than one. Okay, if you want to know x, well, form yourself a triangle like this, and this would be our imaginary sun here. This would be our imaginary sea here. So if you want to know x, it would be well, we don't know the opposite. We only know the hypotenuse. The hypotenuse is one. This distance here is one. So we will need a cos. Okay, cod jumping out of the water. So we will need cos. So if you want to know x, it would be cos theta, whatever theta is. So it could change. 1 minute it could be up here. So theta could change. Well, anyway, cos theta equals x over 1. Okay. Because you start here at x, and then you will hit the hypotenuse. The hypotenuse is actually 1. So really, anything divided by 1 is just x. So x is actually cos theta. Okay. So if you want to know the horizontal distance of this thing here, whatever it is, all you have to do is cos theta. If you want to know the height here, hang on, let me draw this again. If you want to know, hang on, if you want to know the height here, this height here, okay, let's call it y. Well, if this is theta here and this is 1, our imaginary sun is here, so we will need a tan. Okay, so tan. So what am I talking about? We will need a sine. Sorry, sine. From here up here. This is our imaginary sine, imaginary sun, and then we've got a sine to heaven. So we will need sine. So sine theta equals y over this, the hypotenuse. The hypotenuse is 1. So now if you want to know y, oh wait there, y over 1 is just y. So if you want to know y, is just sine theta. Okay, so even if it's even if it's up here, whatever it is up there, um, hang on, hang on, let me draw this again. Suppose it's up here rather than down here. Rather than down here, it's up here. Okay, so so this height here would be sine theta, whatever theta is. Remember, theta could change. It's moving around in a circle. If you want to know, so the height here is just given by sine theta. If you want to know this distance here, it's just given by cos theta. Okay, so all you need to know is the angle here, and then you can find out this distance here. Okay.